Hi everyone. Today we will learn how to implement the server streaming RPC in Go. First, we will define a new RPC in the proto file to search for laptops with some specific requirements. Then we will implement the server, the client, and write unit tests for that RPC. Alright, let's start. I will open the PCBook Golang project that we've been working on. Our RPC will allow us to search for laptops that satisfy some configuration requirements. So I will create a filter message.proto file. This message will define what kind of laptop we are looking for, such as the maximum price that we are willing to pay for the laptop, the minimum number of cores that the laptop CPU should have, the minimum frequency of the CPU, and the minimum size of the RAM. Okay, now we will define a new server streaming RPC in the laptopservice.proto file. First, we define the search laptop request that contains only one filter field. Then a search laptop response that contains only one laptop field. The server streaming RPC is defined in a similar way to the unary RPC. Start with the RPC keyword. Then the RPC name is search laptop. The input is search laptop request, and the output is a stream of search laptop response. That's it. Pretty straightforward. Okay, let's generate the code. In the laptopservice.pb.go file, some new codes have been added. We have the search laptop request struct, the search laptop response struct, then the laptop service client interface with a new search laptop function. Similarly, we also have a new search laptop function inside the laptop service server interface. We will implement the server side first. Let's add a search function to the laptop store interface. It takes a filter as input, and also a callback function to report whenever a laptop is found. It will return an error. Now let's implement this function for the in-memory laptop store. Since we are reading data, we have to acquire read lock. Remember to unlock it afterward. We iterate through all laptops in the store and check which one is qualified to the filter. The isQualified function takes a filter and a laptop as input and returns true if the laptop satisfies the filter. If the laptop price is greater than the maximum price in the filter, return false. If the number of cores of the laptop CPU is less than the minimum cores in the filter, return false. If the minimum frequency of the laptop CPU is less than that of the filter, return false. Now we have to compare the RAM. Since there are different types of memory units, to compare them, we have to write a function to convert the memory to the smallest unit, bit. If the size of the laptop RAM is smaller than that of the filter, return false, else return true. Now let's implement the 2-bit function. First we get the memory value, then we do a switch case on the memory unit. If it is bit, we simply return the value. If it is byte, we have to multiply the value by 8 because 1 byte equals 8 bits. And because h equal to 2 to the power of 3, we can use a bit operator shift left 3 here to avoid multiplication. If it is kilobyte, we have to multiply the value by 1024 and 8 because 1 kilobyte equal to 1024 bytes. And because 1024 multiplied by 8 equal to 2 to the power of 13, we can use a simple shift left 13 here. Similarly, if it is megabyte, we return the value shift left 23. For gigabyte, value shift left 33. And finally for terabyte, value shift left 43. For the default case, just return 0. Now let's go back to our search laptop function. When the laptop is qualified, we have to deep copy it before calling the callback function. Since deep copy is used in many places, I will write a separate function for it. Just copy and paste the code block to this deep copy function. Then in this find function, we simply return deep copy laptop. And the save function can also be simplified like this. In the search function, we deep copy the qualified laptop and call found to send it to the caller. If there's an error, returns it. Otherwise, return nil at the end of the function. Okay, the store is done. Now let's implement the server. We will have to implement the search laptop function of the laptop service server interface. So I will copy this function and paste it in the laptop server.go file. It has two arguments, the input request and the output stream response. The first thing we do is to get the filter from the request. Then we write a log saying a search laptop request is received with this filter. And we call server.store.search, pass in the filter, and the callback function. If an error occurs, we return it with the internal status code. Else we return nil. Now in the callback function, when we found a laptop, we create a new response object with that laptop and send it to the client by calling stream.send. If an error occurs, just return it. Else we write a simple log saying we have sent the laptop with this ID, then return nil. And we are done with the server. Now let's implement the client. First, I will make a separate function to create a random laptop. Let's copy this code block and paste it in the create laptop function. Now in the main function, we will use a for loop to create 10 random laptops. Then we will create a new search filter. I want to search for laptops with maximum price of 3000 and at least 4 CPU cores, minimum frequencies of 2.5, and at least 8 GB of RAM. Now we call search laptop with the client and the filter. Let's write this function. First, we write a log here to show the filter values. Then we create a context with timeout of 5 seconds. We make a search laptop request object with the filter. Then we call laptop client.search laptop to get the stream. If there's an error, write a filter log. Else we use a for loop to receive multiple responses from the stream. If it returns an end of file error, this means it's the end of the stream, so we just return. Otherwise, if error is not nil, we write a filter log. If everything goes well, we can get the laptop from the stream. I will print out only a few properties of the laptop so that it's easier to read. The laptop ID, the brand, the name, the number of CPU cores, the mean frequencies of the CPU, the RAM, and finally the price. Okay, now let's run the server and run the client. There's a deadline exceeded error when creating the laptops. This is because in the previous lecture, we're doing a sleep for 6 seconds on the server side. So let's comment this out and restart the server. Then rerun the client. This time we've created 10 laptops and found one laptop that matches the filter. Let's run it one more time to create 10 more laptops. This time we found 3 matches laptops. Let's look at the server logs. Here it receives a search laptop request and sent 3 laptops to the client. Perfect. Now let's simulate the timeout case. In the search function of the laptop store, let's say it runs very slowly. Each iteration takes 1 second. We write a log here so that we can track the progress. Okay, let's restart the server. Then run the client. After a few seconds, it gets a deadline exceeded error. Let's run it one more time so that the server will have more records to scan through. Okay, the deadline error is thrown. However, on the server side, you can see that it's still checking more records. This is useless because the client has already cancelled the request. So let's fix it. In this for loop, before checking if a laptop is qualified or not, we will have to check the context status. To do that, we have to add the request context as a parameter of the search function. Alright, now we check if the context error is cancelled or deadline exceeded. If it is, we write a log and return an error saying the context is cancelled. In the laptop server, we have to get the context from the stream and pass it in the search function. And that's it. Now let's restart the server. Then run the client. One more time. Okay, this time on the server side, we can see a log context is cancelled and it stops processing other records. So it works as expected. Now I will show you how to write unit tests for the server streaming RPC. There are 2 ways to do this. The first way is to mock this stream interface, provide an implementation of the send function to get the responses. But we also need to add some empty implementation of the function in the gRPC server streaming interface. There are about 6 of them, so it's too much. First, I will use the second way, which is to use the client to call the RPC on the test server. I will copy this setup block and paste it here to make a new unit test. It's gonna be test client search laptop. First, I will create a search filter. Let's say the max price is 2000. The mean CPU core is 4. The mean CPU frequency is 2.2. And the minimum RAM is 8 GB. Next, I will create a new in-memory laptop store to insert some laptop for searching. This expected IDs map will contain all laptop IDs that we expect to be found by the server. Okay, now we will use a for loop to create 6 laptops. The first case will be an unmatched laptop with a too high price. The second case is also unmatched because it has only 2 cores. The third case doesn't match because the mean frequency is too low. The fourth case doesn't match since it has only 4 gigs RAM. The fifth case is going to be a matched laptop. The price is $1999. It has 4 cores with minimum frequency of 2.5 and max frequency of 4.5 and 16 GB of RAM. We add the ID of this laptop to the expected IDs map. The last case is also matched. So I will just duplicate the previous one and change the configurations a bit. Alright, now we call store.save to save the laptop to the store. Require there's no error. Next, we have to add this store to the test laptop server. I will add one more store parameter to this function. Then update the create laptop test to pass in a new in-memory laptop store. Okay, back to our search laptop test. Here we're not gonna use the laptop server object, so I will remove it. Now we create a new search laptop request with the filter. Then we call laptop client.searchLaptop with a created request. We require no errors to be returned. Next, I will use this variable to keep track of the number of laptops found. Then use a for loop to receive multiple responses. If we got an end-of-file error, then break. Else, we check that there's no error. And the laptop ID should be in the expected IDs map. Then we increase the number of laptops found. Finally, we require that number to equal to the size of the expected IDs. Okay, now let's run this unit test. It passed, but it took 6 seconds to run. That's because we forget to comment out the time.sleep in the search function. So let's comment it out and rerun the test. It's much faster now. Let's run the whole package test. All passed, and the coverage is 75.8%. Not bad. And that's all for today's lecture. We have learned how to implement and test the server streaming RPC in Go. In the next video, we will learn how to do that in Java. Thanks for watching, and I will see you later.